Hello everyone, nice to meet you. I'm Xiaoxi Zhang from Thermo Fisher Scientific, and it is my honor to be here to have the chance to give a presentation. Today, I will introduce the latest iCIEF and high-resolution mass spectrometry applications of mAb and ADC charge variance characterization. Here is the outline of my presentation today. I will show you two applications cases. One is about offline fractionation collection followed by peptide mapping, and the other is mass online coupling for real-time intact analysis. First, let me give you a little bit background of both powerful platforms. Last year, we announced a co-marketing agreement to accelerate therapeutic development through cutting-edge protein analysis. So on the right, this is the CEInfinite Automated Preparative iCIEF system, which was developed by Advanced Electrophoresis Solutions AES. And besides iCIEF separation and UV detection, this system also provides automated preparative workflow, which enables offline fractionation collection for LC mass-based peptide mapping, and it also can be applied for iCIEF mass online coupling. The two instruments on the left are Thermo Vanquish Flex UHPLC system and Q Executive Plus Biopharm High Resolution Mass Spectrometry, which are used in both peptide mapping and intact protein analysis. Benefited from high resolution, sensitivity, and robustness of Orbitrap platform, users can get high quality and most informative peptide mapping and intact protein results. So we all know charge variant analysis is important because the charge variation of maps reflects the sum of various PTMs, as you can see here, and characterizing biologic charge isomers is useful for many life cycle stages, including cell line selection, stability studies, formulation, and processing control. That's why the analysis of charge variance is a regulatory requirement for biotherapeutic proteins. But this characterization requires the proteins to be separated into divided charge fractions with enough purity for downstream assays. So during the offline fractionation, the charge isomers are separated by their pi value and collected in turn. The automatic preparative workflow provides the following advantage and benefit. The patented cartridge can separate pi difference down to 0.01, and one typical run is usually less than 1 hour. And by citing automated sequence, the system allows around 100 microgram protein collection per day. And once these separation and collection procedures are done, the fractions can be used for a series of physical and chemical characterization, such as LS mass-based analysis and bioassay. So here, in the first case, a CEInfinite Preparative iCIEF system was used for offline fractionation of charge variants of pembrolizumab, a highly selective anti-PD-1 humanized mAb, followed by a comprehensive peptide mapping analysis using UHPLC mass system. In this study, we successfully collected 5 peaks, including 2 acidic peaks, 2 basic peaks, and a main peak. For subsequent peptide mapping analysis, the collection procedure is automated and around 160 microgram protein was separated and fractionated in 2 days. Each well was a combination of 15 to 20 runs, and the fractions were reduced, then digested with trypsin. So in this experiment, selected PQAs including terminal modifications, N-glycans, and sand chain modifications such as deamidation, succinimidation, and oxidation were identified and relatively quantified in all acidic, basic, and main peak. On this page, the upper left finger shows the terminal modifications in all peaks. The lysine clipping percent in basic peak 2 is around 69% and 91% in basic peak 1 compared to the lysine clipping in main and acidic peaks are nearly complete. In basic peak 1, only around 30% pyroglutamate cyclization was detected, while 94 in main peak, 92 to 96 in both acidic peaks, and 93 in basic peak 2 were detected. And below is a high-quality mass2 spectrum of modified peptide and fragment coverage map. The right finger is the percentage of N-glycan in all peaks, and it is noteworthy that the percentage of sialic acid contained glycoforms increased 5 to 10 times in acidic peaks compared to main peak. Also, the relative abundance of A1G0F increased significantly in basic peaks. Then let's turn to the sidechain modifications. Here, the upper left finger shows heavy chain N55 deamidation and succinimidation in main and acidic peaks. The level of these deaminations set modification percent is within the CDR domain is 0.18 in main peak compared to 0.93 in acidic peak 1 and 0.83 in acidic peak 2. It is easily to observe that the area of the deaminated peaks increased, and heavy chain N55 succinimidation level decreased in acidic peaks compared to main peak. And the finger below is the percentage of oxidation in all peaks, and oxidation increased significantly in basic peaks across multiple sites compared to their levels in the main peak. And on the right, the table compares the modification percentage before and after iCIEF separation in main peak. Before, we can see here, better separation helps more precisely CQA relative quantitation, which provides more meaningful information about CQAs. Okay, so the second case is about the online coupling experiment. Here, a CEInfinite iCIEF coupled with an orbitrap mass spectrometry were used for analyzing charge variance of pembrolizumab and TDM1. So, the direct coupling of iCIEF to mass spectrometry for characterization would accelerate the characterization process significantly. And here, we don't need any extra mass source interface. And also, for the makeup liquid, which is help to push the separated charge variance into mass spec. Here you may use any buffer or solution as the makeup liquid, and no chemical mobilization is involved. Then, when we think about the method transfer, they proved any proved CE-based technology method can be transferred straightforwardly from existing iCIEF or CIEF method, makes it easier for the method transfer. Here shows the online coupling results on pembrolizumab. In this study, 8 peaks were successfully separated, including 4 acidic peaks, 3 basic peaks, and main peak for subsequent online intact protein analysis by mass spectrometry. And it is easy to find out that the separation is pretty good, even for very close peaks. And figure A describes the comparison of the raw spectra of basic peaks and main peak. It is easy to observe mass shift even at raw spectrum level, because basic variants are mainly caused by heavy chain C-terminal truncation, heavy chain N-terminal pyroglutamate cyclization, and oxidation. Benefiting from the high sensitivity of orbitrap mass spectrometry, trace variants like the basic peak 3, which is only 4.8 nanogram on column, can be detected with good signal-to-noise ratio and leading to a confident deconvolution spectrum in finger B. And finger C is a mirror plot of main peak, PI equals 7.57, and basic peak 1, POI equals 7.59 deconvolution results. And a series of 17 Dalton mass shifts can be detected for every glycoform in the basic peak 1. The reason is that compared to main peak, only one glutamate and N-terminal of heavy chain was cyclized to form pyroglutamate. And this intact protein analysis results corresponds with the previous peptide mapping results as displayed here. All charge variance identification results are summarized in this table. For basic peaks, the main PTM cause charge variants are heavy chain C-terminal truncation, heavy chain N-terminal pyroglutamate cyclization, and oxidation. All the modification details can be clearly read out in the mass intact results. For example, GK truncation minus 185 Dalton was identified on C-terminal of both heavy chains in the lowest peak, basic peak, peak 3, as it's shown here, which is 2 orders lower than the main peak. In acidic peaks, series of deamidation and different sialic acid modifications were identified. And for this work, we also use TDM1 for online identification. And TDM1 is an antibody-drug conjugate consisting of the humanized monoclonal antibody Herceptin conveniently linked to the cytotoxic agent DM1. For this lysine conjugated ADC, different drug loads from D0 to D10 were clearly separated at iCIEF-UV level. This represents a meaningful result because this isoform can't be separated on routine RPLC mass system. We know ADCs are complex molecules composed of an antibody linked to a biologically active cytotoxic payload or drug, so charge-based separation before intact mass analysis can significantly reduce the complexity of spectra, making the deconvolution results more easier. And here we compared the mass spectra and deconvolution results of RPLC mass and iCIEF mass, and found out that using the iCIEF strategy, separation of ADC with different drug loads reduce the interference of mass signals from adjacent charge states and drug payloads. Therefore, the deconvolution was simplified. As we may see here, this is the iCIEF mass spectra and deconvolution results comparison before and after iCIEF separation. It is easy to find out that before separation, mass signals from adjacent charge states and drug payloads are overlapped, increasing the complexity of the spectrum. And the complexity of mass spectra was significantly reduced due to iCIEF separation before mass detection. So that makes the deconvolution more easier. Okay, let me summarize my contents today. In this work, we established and validated both iCIEF online preparative and we established and validated both iCIEF offline preparative and online mass coupling workflow. The LC mass-based peptide mapping analysis provided in-depth characterization of PQAs and comparison of their relative abundance level in acidic and basic peaks, and the online coupling workflow successfully separated and achieved real-time intent protein analysis of pembrolizumab and TDM1 charge variants. And also, this is a simple system for reproducibility and method developing and transfer. Okay, that's all for my presentation. Thank you for listening.